7.2, proportions. Okay, so I'm going to start over here on the right and then move to the left because the right kind of supports it. A proportion is just the equality of two rates or ratios. Well, in mathy terms, A is to B as C is to D. If and only if. This is a biconditional statement. What I typically relate to is something that isn't a biconditional, like if it's a horse, it has four legs. Okay, so unless you cut off a horse's leg or it's born deformed, traditionally horses have four legs. So this is a true statement in that direction. If I were to reverse it and say if it has four legs, then it is a horse. Okay, that's not true because I can think of a cow which has four legs, a cat, a dog, a rhinoceros. I mean, there are lots of things that are not horses that have four legs. So that is a conditional statement. If it's a horse, it has four legs, but it's not biconditional. You can't reverse it and get the same thing. This is a biconditional. If it's a proportion, so if two ratios are set equal to one another, then the extremes are equal to the means. This was an old adage. It's really not used all that much anymore other than like, oh, that's nice. But what it's saying is that their cross products are also equal. So if two things are in proportion, then their cross products are equal. If their cross products are equal, then the two things are in proportion. So it flows both directions. So it helps to have a little algebra to do this. That's why I said, hey, let's do a little bit over here. I'm going to come up with another piece over here to show you the same method applies no matter what the number is. But if I have a number in front of a variable, like x seems to be the favorite, all I have to do is divide both sides by that number. So 3 divided by 3 is 1, leaving me with just x. 6 divided by 3 is 2. Now you can look at this one and say, okay, well 3 times 2 is 6, so x must be 2. Well, that's good. So now if I have something like 2/3 x is equal to 7, it's a little tougher, but the same process applies. You divide by the number, you divide both sides by the number in front of x. Now 2/3 divided by 2/3 is still 1. We still get x. Over here, though, we got to be careful because this, even though it didn't look like it, this was actually 7/1. So now we have fractions dividing. We flip this and multiply. That's going to give us, and multiply straight across, that's going to give us 21/2. So x is 21/2. Now, could you have guessed that? Sure, I guess, if you're that good. I wouldn't have. So this is a good method to use, especially when you can't guess. If you can just look at it and decide, by all means, go ahead. So that's the little bit of algebra that we're going to use. Because when we solve these things, it's going to kick it into, we're going to actually use this idea of the proportion to solve these. And it's going to kick it into something times x equals something. And we got to solve for x. So to write this from words, this is kind of weird, but it kind of plays into what we did in 7.1 with rates and ratios. 9 is to 14 as. The as is the equal sign. 27 is to 42. And we can double check that, and we can go through and see if that's in fact a true proportion by cross multiplying. So I draw my arrows like this. It is for the proportion. It is not for division of fractions. Do not use it for that, please. 9 times 42 is equal to 14 times 27. And let's see if I... Anyway, I'm going to try to do this in my head. I didn't bring a calculator with me. Let's see. No, that's not going to be easy. 36 and 18, 37, 8. 378. Double check this. Is equal to, ew, gross, times 10. This is almost 15, so times 10 is going to give me 270, and then 135 would be 405, minus 27. Minus 25 would be 380 minus 2 is going to give me 378. So yep, so works. Check. It's good. So this is a true proportion. We checked it with the other half. So we're saying 1/2 is true, then the other half must be true. That's how we check it. All right, next little example here. 3 people absent is to 31 people present. So 3 people absent is to 31 present as 15 absent is to 155 present. Okay, so now I'm going to do this in a slightly different way because the numbers are going to get gargantuan, and I just don't feel like getting a calculator. I'm feeling very lazy today. You can also do this by scaling. So if you can guess what you can multiply 3 by to get to 15, it's times 5. Then the question is this also times 5? If it is, it's proportion. If it's not a proportion. So 31 times 5 is, well, 30 times 5 is 150. 1 times 5 is 5, and 150 plus 5 is in fact 155. So if I were to multiply this all out, that's 465. Be 465 equals 460. The other 65. You notice I am not putting in what is being measured here because it doesn't make any sense. And then this would also be 465 if you multiplied the 15 and the 31 and then the 3 and the 155. You know what? I'm not even going to show you because I think it's going to be more confusing. Just trust me on this. As long as the top and the bottom agree, notice the absents are up top, the presents are on the bottom. As long as those agree, as far as the types of measurements, life is good. Ignore the measurements. Do the thing. It's going to make your life so much less complicated. So here are, making sure, okay. There are 3 examples. And so we'll just work through these together. With this first example here, I'm going to cross multiply. When I do that, I get 15x is equal to 30. Just like from above, I said anytime you see something multiplying x, divide both sides by that thing. 15 divided by 15 is just 1, so we get x. 30 divided by 15 is 2. Again, if you knew that, oh wow. Hang on. Oh yeah, duh. Jeez, Pete. If you did the, sorry, my mind just brain farted there for a little bit. If you did the, I'm gonna do this in deep purple here. If you did the scaling, you would say this is times 3 to go that way. So what times 3 is 6? 2. So I would have to put a 2 here. So x would have to be 2. So it's another way to do it, another way to think about it. All right, next one here. Again, I'm just going to cross multiply. It doesn't really matter. Once I'm into the proportional form, I just cross multiply. That's going to give me 8x is equal to, now this is not as nearly as easy. This is going to be 210, 216. And then I have to divide both sides by 8. Okay, so again, I don't have a calculator and I'm sort of cheating on the side of my brain here, so this should be 27. I don't have the answer in front of me. I knew that 216 was 6 cubed, and then I broke down the 6's into 3 2's and 3 3's. Anyway, so x is 27 in that case. So if I put a 27 on the bottom here, it will be in proportion. And then finally we have this last piece here. This is probably where I would say doing it through the proportional method, where you're trying to find the cross multiplier or the cross products. It's gonna suck. There's just no other way to put it. It's gonna hurt a lot because the numbers are huge. It is not the way I would have chosen to do it. And here, let me explain how I would have done it first, and then we'll look at cross products. I'm going to go that direction. So in order to do that, I got 30 times 2 is 60. So I just have to simply multiply this by 2, and I'm there. Well, 2 times 60 is 120. 2 times 10 is 10, or 2 times 5 is 10. 120 and 10 is 130. So x equals 130. Now we'll do it. Now that we have that, we'll do it the correct way. Anywho, cross multiplying is going to give us 3600, 3900 equals 30x. All right, now your brain will probably get stuck on this whole idea that x belongs on the left-hand side. It's not necessarily true. You can have it on either side. If it just feels better to you to have it on the left-hand side, by all means, just reverse this equality and you're good. These two things, 30x is equal to 3900. These are the same thing, so it doesn't really matter. But just like before, I'm going to divide by the thing in front of x on both sides. 30 divided by 30 is 1, leaving me with just x. I can cancel out the times 10 here, so now I just have to divide 39 by 3 and add a 0. That's 13, add the 0 for 130. So either way you go, you're going to get 130. And that's proportions. That's how you do them all. Just keep in mind, again, especially when we get to 7-3, keep the same types of measurements on top and bottom. It doesn't really matter what they are as long as they're the same type. As long as that's true, you'll be okay. All right, I hope this helps.